In section 4, we're going to talk about the double and half angle identities because it's going to be useful to find the trig values for angles that are half or double of one of our known angles on the unit circle. So we have first our double angle identity. So sine of 2 theta has its own formula. Cosine of 2 theta actually has 3 different formulas that can be used to find it. So it's completely based on what information you're already given. That can usually determine which of the cosine double angle identities you're going to use. And then lastly, we have a formula for tangent of 2 theta. So let's go ahead and start with an example. So given that sine of beta equals negative 2/3 and beta is between 3 pi over 2 and 2 pi, we want to find cosine of 2 beta, sine of 2 beta, and tangent of 2 beta. So the first thing to determine is what does this beta between 3 pi over 2 and 2 pi tell us? It actually tells us what quadrant we're in. And 3 pi over 2 and 2 pi is quadrant 4. So that's going to help us determine signs of ratios that we may need to find. So let's start with cosine of 2 beta. So when determining which identity to use, let's see, we want to use one that it's going to involve sine. And if we look, the second identity for cosine of 2 beta is 1 minus 2 sine squared of beta. So we can use this identity to find cosine of 2 beta. Well, we already know sine, so it becomes 1 minus 2 times negative 2/3 squared. So we get 1 minus 2 times, and then negative 2/3 squared is going to give us 4/9. So we're going to get 1 minus, and then 2 times 4/9 is going to give us 8/9. So our final answer, 1 minus 8/9, is 1/9. So cosine of 2 beta is going to be 1/9. Next, let's take a look at sine of 2 beta. Well, there's only one identity used for sine of 2 beta, and that's 2 sine of beta times cosine of beta. So in order to find the double angle for sine, we actually have to know sine and cosine. So what we're going to do is we're going to use a Pythagorean identity to help us find cosine. So I'm going to do that up here. So we're going to use the fact that sine squared of beta plus cosine squared of beta equals 1. So we know sine is a negative 2/3, so negative 2/3 squared plus cosine squared of beta equals 1. So we get 4/9 plus cosine squared of beta equals 1. Subtracting that 4/9, we get that cosine squared of beta equals 5/9, and then taking the square root, we get that cosine of beta equals radical 5 over 3. Now this is where that quadrant comes back into play again. So in quadrant 4, cosine is positive, so we don't have to add a negative out in front. Cosine of beta is a positive radical 5 over 3. So you always want to pay attention to what quadrant you're in. So if you have to solve for a trig value, you know if it's going to be positive or negative. So going back to our equation, we now have sine of beta and cosine of beta. So it's going to become 2 times sine of beta, which is negative 2/3, times cosine of beta, which is a radical 5 over 3. So now when we multiply, this 2 only multiplies to the negative 2 and the radical 5. So we end up with negative 4 radical 5 over 9. And that cannot be simplified further, and that's our final answer. So lastly, we want to take a look at tangent of 2 beta. So tangent of 2 beta, the identity for tangent is 2 tangent of beta over 1 minus tangent squared of beta. Well, in order to find tangent, we know that tangent is sine over cosine. So we know that tangent of beta is going to equal sine of beta over cosine of beta. Sine is a negative 2/3 over cosine, which is a radical 5/3. And because we're dividing two fractions with the same denominator, we end up with negative 2 over radical 5 for tangent. So back in our equation, we now have 2 times negative 2 over radical 5 all over 1 minus negative 2 over radical 5 squared. So the rest of this is just simplifying. So we end up with negative 4 over radical 5 all over 1 minus, and then negative 2 over radical 5 squared is going to give us 4/5. So that ends up being negative 4 over radical 5 divided by, and then 1 minus 4/5 is going to be 1/5. Now, unfortunately, we're not dividing two fractions with the same denominator, so we are going to rewrite this as multiplication. So we're going to get negative 4 over radical 5 times the reciprocal of our denominator, which is going to be 5/1. And we're going to end up with negative 20 over radical 5. And I am actually going to rationalize the denominator here because it does simplify to give us a different answer. So multiplying the top and the bottom by radical 5, we end up with negative 20 radical 5 over 5, which will simplify to give us a final answer of negative 4 radical 5. So in some cases, rationalizing the denominator does give us a nicer looking answer, if you will, than leaving it as a radical. So let's look at another example. So cosine of alpha is negative 7/9, and alpha is between pi over 2 and pi. We want to find the exact value of sine of 2 alpha. Well, let's first determine what quadrant we're in. So pi over 2 and pi is quadrant 2. So let's first write out our identity for sine of 2 alpha, which is 2 times sine of alpha times cosine of alpha. So not only do we need to know cosine of alpha, we also need to know sine of alpha. So over to the side here, I am going to use the Pythagorean identity to help solve for sine of alpha. So I'm going to use sine squared of alpha plus cosine squared of alpha equals 1. So we have sine squared of alpha plus negative 7/9 squared equals 1. So sine squared of alpha plus 49 over 81 equals 1. Subtracting 49 over 81 from both sides, we get sine squared of alpha equals 32 over 81, and then we take the square root, and we get sine of alpha equals, and we do want to simplify our radical. So though we can't take the square root of 32, we can simplify it, and it simplifies to give us 4 radical 2 over the square root of 81, which is 9. And again, quadrant, check what quadrant you're in. In quadrant 2, sine is positive, so we don't have to add a negative in front of that. So now we can go back and plug in our information into our double angle formula. So sine of 2 alpha is going to become 2 times sine, which is 4 radical 2 over 9, times cosine, which is negative 7/9. So this 2 multiplies to the 4 radical 2 and then negative 7. So we end up with negative 56 radical 2 all over 9 times 9, which is 81. And this is the value of sine of 2 alpha. So notice here that just because we've doubled an angle, it does not mean that the ratio, the trig value, is also doubled. That relationship does not hold. So let's go ahead and verify identities with using our double angle identities. So we want to verify that sine of x plus cosine of x squared equals sine of 2x plus 1. So what we're going to do is we're going to expand that left side and simplify it to the right. So when I expand sine of x plus cosine of x squared, it's sine of x plus cosine of x times sine of x plus cosine of x. Remember, we cannot distribute that squared into the parentheses because of our addition sign. So now we're going to distribute. So we get sine squared of x plus sine of x times cosine of x plus sine of x times cosine of x plus cosine squared of x. So now we want to start looking for identities we can use to simplify our answer further. So I'm going to start grouping terms to use identities. So first I'm going to notice I have a sine of x cosine of x and another sine of x cosine of x. So that's going to give us 2 sine of x cosine of x. And I still have the plus sine squared of x plus cosine squared of x. So now I'm going to use identities again. 2 sine of x cosine of x is the double angle formula for sine. So I can rewrite that as sine of 2x. And also, sine squared x plus cosine squared x is a Pythagorean identity, and it equals 1. So I get sine of 2x plus 1, which is what I wanted to show. So I verified that the left side does equal sine of 2x plus 1. Next example, we want to verify that cosine of 2 theta equals 2 minus secant squared theta over secant squared theta. Now, 2 minus secant squared theta is not a Pythagorean identity, so that's not going to help us. So we could rewrite everything in terms of sine and cosine and simplify that way, but because of that subtraction in the numerator, we can actually break up our fraction into 2 terms. So we get 2 over secant squared theta minus secant squared theta over secant squared theta. Now, if that had said 1 over secant squared theta, we could rewrite it as cosine squared theta. So with the 2, that just means we write it as 2 cosine squared theta minus secant squared theta divided by secant squared theta is 1. So we get minus 1. And 2 cosine squared theta minus 1 is one of our double angle identities for cosine. So we end up with cosine of 2 theta equals cosine of 2 theta. So the last thing we have to look at are the half angle formulas. And if you notice, all of the half angle formulas have a plus or minus in front of them. So what that means is we have to figure out what quadrant our half angle falls in, and then we determine if it's positive or negative based on that. So let's take a look at our first example. So we want to find sine of negative pi over 8. So negative pi over 8 is in quadrant 4. So you would go down from 2 pi, and sine is negative in that quadrant. So we know sine is going to be negative. Now we just have to determine what angle we divide by 2 to get negative pi over 8. And that is going to be negative pi over 4. So for our half angle identity, we are going to do sine of negative pi over 4 divided by 2 equals negative square root 1 minus cosine of negative pi over 4 all over 2. So that's going to be negative square root 1 minus, and then cosine of negative pi over 4 is radical 2 over 2, still all over 2. So rewriting our numerator as a single fraction, 1 can be written as 2 over 2. We end up with 2 minus radical 2, all over 2, all over 2. Now when we're dividing a fraction by a number, we end up multiplying the denominator. So we get negative square root of 2 minus radical 2 all over 4. Now we can't take the square root of the numerator, so our numerator is going to stay square root 2 minus radical 2, but we can take the square root of the denominator, so now we end up with just a 2 in the denominator, and the only place that your square root should fall over is the numerator. Next, we want to find cosine of pi over 12. Well, cosine of pi over 12 is going to be in quadrant 1, and cosine is positive in quadrant 1. Next, we want to figure out what angle we divide by 2 to get pi over 12. And that is going to be pi over 6. So our cosine half angle formula is going to be cosine of pi over 6 divided by 2 equals the square root of 1 plus cosine of pi over 6 all over 2. So using our unit circle, we get 1 plus radical 3 over 2 all over 2. Similar to the previous example, we're going to rewrite our numerator as a single fraction. So we get 2 plus radical 3 all over 2 all over 2. And then we're going to multiply our denominator, so we end up with 2 plus radical 3 all over 4, still all underneath a radical. And we can't take the square root of the numerator, so our final answer is going to be the square root of 2 plus radical 3, and then over the square root of 4, which is just a 2. So last example, we want to find tangent of 15. Well, 15 degrees is in quadrant 1, and tangent is positive in quadrant 1. And then the angle we divide by 2 to get 15 is 30. So we're looking at our alpha being 30 degrees. So we're going to have tangent of 30 over 2 equals the square root of 1 minus cosine of 30 over 1 plus cosine of 30. Using our unit circle, cosine of 30 is radical 3 over 2. So we have the square root of 1 minus radical 3 over 2 over 1 plus radical 3 over 2. Rewriting both our numerator and denominator as single fractions, we get the square root of 2 minus radical 3 all over 2 divided by 2 plus radical 3 all over 2. Now we are dividing two fractions with the same denominator, so those will cancel and we'll be left with the square root of 2 minus radical 3 over 2 plus radical 3. And this does not simplify any further, so this would be our final answer. So our last two examples, we're given that tangent of theta is 7/9, where theta is in quadrant 2, and we want to find sine of theta over 2 and tangent of theta over 2. So first we have to determine what quadrant we're going to end up being in. So if I have an angle in quadrant 3 and I want to find its half angle, I am not actually going to still be in quadrant 3. So if I take half of an angle in quadrant 3, theta over 2 is actually going to be in quadrant 2. So when I'm picking my signs for sine of theta over 2 and tangent of theta over 2, I have to use their quadrant 2 properties. So when I write off the half angle formula of sine of theta over 2, in quadrant 2 sine is positive. So we get the square root of 1 minus cosine of theta over 2. So in order to do my half angle, I have to know cosine, and I was given tangent. So what I'm going to do is I'm going to draw the triangle. So tangent is 7/9, so the opposite side is 7, the adjacent side is 9, and theta is in quadrant 3, where both of these are negative. And then using the Pythagorean identity, we end up with the hypotenuse as the square root of 130. So now I can go ahead and plug that ratio into my formula. So we get the square root of 1 minus negative 9 over radical 130 all over 2. And I'm going to combine two steps here. I'm going to write it as a single fraction, and if you notice, change the minus and negative to addition. So 1 is square root 130 over square root 130, so we get the square root of 130 plus 9 all over the square root of 130 all over 2. When I'm dividing this fraction, I'm still going to multiply the denominators, so we end up with the square root of radical 130 plus 9 over 2 radical 130. And we're not actually going to be able to simplify that further. So last we find tangent of theta over 2. Well, in quadrant 2, tangent is going to be negative. So tangent of theta over 2 is going to equal negative square root 1 minus cosine of theta, so over 1 plus cosine of theta. Well, we just found cosine to find sine of theta over 2, so we don't have to re-find our ratio. So we get negative square root 1 minus negative 9 over square root 130 over 1 plus negative 9 over square root 130. And I'm going to combine steps again. I'm going to rewrite as a single fraction and also change the signs. So we get negative square root. Our numerator is going to become radical 130 plus 9 over radical 130. And our denominator is going to be radical 130 minus 9 over radical 130. So in this example, we're dividing two fractions with the same denominator. So the denominators will cancel, and we will end up with negative square root radical 130 plus 9 over radical 130 minus 9. And this answer is not going to simplify, so that is our final answer. So you may have noticed this, but with the half angle identities, every half angle formula involves knowing cosine. So it's going to be very important to get familiar with cosine when you're trying to find half angle identities.